Okay. When will the angular momentum of a system be constant? So this is kind of another parallel that we have with linear motion. So our angular momentum is defined as I omega, at least, actually no, that seems pretty good. So L will be constant. So L is obviously going to be a constant if our omega is constant, as I is just our mode of inertia. As similar to linear motion, we can do a conservation of angular momentum. So L1 equals L2. So we can have changes in these quantities in I or omega, but omega must always be constant in either case. So what I mean by that is really alpha is d omega by dt, and so that must be 0. And so if our alpha is 0, even if, say, omega changes, so we go from one value to another value, as long as there's no long-term acceleration, angular acceleration, then our L should be constant. So another way of saying this, though, is since our torque is I alpha, again, very similar to linear motion, its L will be constant with no external torque. Right, so again, think of linear motion, and our momentum is constant with no external force. So there's a parallel in almost every way between angular motion and linear motion, and it kind of makes it a little easier to remember this stuff. So our L is constant as long as there's no external torque acting on the system, or no net torque acting on the system, as we need our alpha to be 0, and so our torque has to equal 0. Yeah, so then our angular momentum will change if there's a net torque on the system. So that seems pretty good. So that's just I omega. We'll get angular acceleration if there's a torque, and then the angular momentum will change. So that looks good.